So this is a setup for this lens thing, and before we move on, we missed out something just now. This one, rim wind. Rim wind is the cases of real inverted magnified and virtual inverted magnified. Seems like a lot of M, must be microscope. See, seems like a lot of M. So now we look at the setup. You have 2 FO here and FO here, FO here, FE here, and 2 FO here. When we say rim wind, we know that rim stands for the middle guy, so the object is placed here. So we have a distance of U between 2 FO and FO. Okay, so the image form, if we use geometrical construction, we go through parallel, we strike the first FO. Okay, the other one we strike the optical center. It seems like this line is not appropriate. Let's do it one more time. This one goes through the middle. Okay, let me readjust this one because the image form is supposed to be at more than 2F, more than 2 FO. Okay, so it should be like this, where your image is actually being formed at this position. Okay, so this is real inverted and magnified. So this blue arrow is an image for the objective lens. Okay, so after some time, the blue arrow has become an object for the eyepiece lens. This is quite evident from here. You have FE. When you have FE here, seems like the image for the objective lens, the blue one, now has become the green one and become an object which is less than FE. It becomes an object less than FE. Okay, of course this is FE, this is FE, but the distance here is actually less than FE. So because of this, we can look at this one. If the image starts from places where it is less than FE, so we know that the image being formed will be virtual, upright, and magnified, evidenced by a very ugly monkey. But one thing you need to know that this image has already been inverted. This image has already been inverted. So if you upright and inverted image, let's do one example. This already inverted. Okay, I put here INV. If you upright the inverted image, it's like you try to positive the negative number. So you still get negative number nevertheless. So because of this, the VUM has to be modified. So you put very inverted, very intelligent monkey. But doesn't matter, you just remember rim wind. But even if you don't remember, we can do some drawing here. So we try to cut off this graffiti. We'll cut off all this. And then we try to draw. Okay? So now we try a different set of color. So here, this image will go straight, and FE should be around here. Draw it longer. FE is supposed to be around here. Okay, so your color, your ray, this one will try to go to F. Okay, not perfectly drawn. Let's do it one more time. It shall go through here. Okay, when it shall go through here, and the other one should go through the optical center. So because of these two rays, they cannot meet anywhere here, so you extrapolate them. When you extrapolate them, the final image is being formed somewhere here. Final image. So this image is a virtual upright, virtual inverted and magnified. Let's imagine you have H2 here with a circle, HO here with a circle, H1 here with a circle. This is the height of the arrow. And because of this, we want to find out more about the magnification. The rules for grand magnification, which is total magnification for two lenses, is MO times ME. But how does this happen? Do you realize that the grand magnification is H2 over HO? H2 over HO can be extended to be H2 over H1 times H1 over HO. If you look carefully, H2 over H1 is the magnification of the eyepiece lens, which is H2 over H1. This one and this one. Then you have H1 over HO. H1 over HO, which is here and here, is the magnification of the objective lens. And so because of this, H2 over H1 is the magnification of the eyepiece lens, and this H1 over HO is the magnification of the objective lens. That's why you have MO equals to MO times ME. Okay? Or you can just remember grand magnification as MO. This one. Grand magnification as MO. So the characteristics is rim. So for rim, you should have U less than FE. So your V is behind you somewhere. Okay. So this V will have a negative value because it's virtual.